In this example, we're asked to find the volume common to two cylinders, each with a radius r, if the axis of the cylinders intersect at right angles. The key to catching on to this problem and getting its volume is to recognize that if I were to slice this resulting figure at any particular height, what I end up with is a square. Cross sections are squares. When that's the case, then we have the ability to just figure out what the lengths of those sides are in each square. Okay? So what I'm going to do is I'm going to look at this thing, I'm going to look at it looking down this tube right here. I'm going to look down that angle as though I'm looking through this circle right here. What I'm going to notice is, as I look down that end, I see a circle, and the length of the side at any height that I choose is the length of this side right here along that edge of the gold cylinder. Okay? So think of this as choosing a particular y value on this y-axis, x-axis here. If I know the length of this side, then the area of the cross-section is going to be the side squared, just like we had on the previous example. Now, if this is in fact a circle, then remember the equation for a circle is x squared plus y squared equals the radius of the cylinder. So now since I'm choosing y, I'm going to solve for x. X turns out to be plus or minus the square root of r squared minus y squared. And my y's are going to range from negative r up to positive r, because that's the radius of the circle, right? So no matter where I draw my radius, it's going to go out r. So since I'm going straight down, it's negative r. Since I'm going straight up, it's to positive r. Okay? So here's what I get. My side length is from this side of the curve to this side of the curve, which happens to be, now that I know these two curves, square root of r squared minus y squared minus a minus square root of r squared minus y squared. And I'm going to square that. And I forgot the pi, by the way. No, it's not a pi, because it's sorry, it's late in the day. I apologize. It is because it's a square. It's just the side squared. So here's what I get is 2 inside square root of r squared minus y squared. Quantity squared. So that becomes 4 r squared minus y squared. And I want to integrate that from negative r to positive r. So to do that integral, I'm just going to treat that as 4r squared minus 4y squared. Integral from negative r to positive r dy. That gives me, I forgot my dy over here. That gives me a 4r squared y, because r is a constant, minus 4 thirds y cubed, or 4y cubed over 3, from negative r to positive r. So I get that that is in fact equal to, plugging in r, I get 4r cubed, because I'm sticking in this r here and here. So 4r cubed minus 4 thirds r cubed minus, now plug in the minus r in both those places. So that becomes a minus 4r cubed, because of minus r times r cubed. And this becomes a minus r cubed, and that minus makes it plus 4 thirds r cubed. So this minus and this minus make the plus, and this minus and this minus make the minus, so you end up with 8r cubed minus 8/3 r cubed. That's 24 minus 8, which is 16r cubed over 3. Interestingly, you may or may not notice this, that's the same area we got, so same volume we got for the previous example. Thought that was kind of cool. That is the volume of that shape of two intersecting cylinders.